Good afternoon all. I am Dr. Tanushree Basak from Physics Department of Indus University. Today I am going to give you a brief overview of the evolution of our universe. I believe that each one of us gets mesmerized to see the view of a starry night, a sky full of stars and galaxies. That is our universe. Now, if you see the present view of our universe through the Hubble Space Telescope, then it will show us the ultra deep field view of our universe that is filled with billions of stars and galaxies. Now, have we ever wondered how it all began, how the universe came into existence? That is where the story begins. So, it is believed, out of many theories, the most convincing theory till date is the theory of Big Bang. So, the universe is believed to start with a Big Bang. What is Big Bang? Big Bang is nothing but a gravitational singularity. It is a singularity in space and time. It is said that nothing exists before Big Bang. No time, no space exists before Big Bang. So, during the phase of Big Bang, the universe is believed to be extremely hot and extremely dense. Afterwards, the universe went through different phases of the evolution, and now as we see it. So, if we go back in time to tell the story of Big Bang, we need to go back very far back in time, far back in time, nearly around 13.7 billion years ago. It started with Big Bang. Now, historically, the theory of Big Bang was proposed in nearly 1927, when Georges Lemaitre, a Belgian cosmologist, proposed the theory of expansion of the universe. In subsequent year, in 1929, Edward Hubble then gave a comprehensive foundation, observational foundation of Big Bang through the theory of Hubble's law. According to Hubble's law, the galaxies are receding from each other at a velocity that is directly proportional to the distance of each other. Finally, in 1931, Georges Lemaitre proposed the theory of Big Bang. He proposed that the universe started with the explosion of a primeval atom, which is now today known as the Big Bang theory. Now, after the Big Bang, the era was known as Planck era. From the 0th second to the 10 raised to minus 43 second, that is known as the Planck time scale. So, during that phase, it is known as the Planck era. So, during that time, all the fundamental forces of nature, namely the strong and weak nuclear forces, then electromagnetic and gravitational forces, all were unified as a one fundamental force. So, now the quantum effect of gravity that dominates the particle interaction during that time. After the end of the Planck era, there came the grand unification era that started nearly 10 raised to minus 43 second, and it lasts until 10 raised to minus 36 seconds. So, during that time, the gravity separates from the other three fundamental forces, which were still unified. Then, after the Gauss era came a very interesting phase of the evolution of universe, that is known as the cosmic inflation. So, during that phase, that is nearly 10 raised to minus 36 second to 10 raised to minus 33 second, the universe underwent an expansion at a very rapid pace. It is said that the expansion is exponential, and the volume of the universe increased to nearly 10 raised to 78 times. Okay. So, that is the phase of cosmic inflation. Now, the theory of inflation mostly developed in the late 70s and in the early 80s by major contributions of the theoretical physicists, namely Alexei Starobinsky, then Andre Linde and Alan Guth. So, according to them, the cosmic inflation is the phase when the universe had an exponential expansion and the volume increases grossly. It is again believed that inflation, actually the fluctuations in the microscopic region during this phase is the seed for the large scale structure formation of the universe. The particle physics behind this inflation is not yet known. Only we know that there is a particle, hypothetical particle known as inflaton, that is responsible for this inflation. There are several theories of inflation. If we see the inflationary epoch, we will see that in such a short span of time, that is 10 to the minus 36 to 10 to the minus 33 second, the universe has expanded to about 10 to the 70 times. After that came the electroweak era. The electroweak era started actually during the inflation and it lasted up to 10 to the minus 12 second. Okay. So, during that electroweak era, the strong nuclear force separated from the other fundamental forces and thus by releasing a huge amount of energy which is believed to have triggered the cosmic inflation. So, extremely energetic particles were created during that time and this electroweak era ended when the electromagnetism separates from the weak force. So, that is the time when the exotic particles like W bosons, Z bosons and Higgs bosons were formed. Afterwards came the elementary particle era that started nearly around 10 to the minus 10 to minus 12 second and it continued up to the first 3 minutes of the universe. Okay. So, we can divide the elementary particle era into 3 parts grossly, that is the quark epoch, the hadron epoch and the lepton epoch. First comes the quark epoch. So, during the quark epoch, that is around 10 to the minus 12 second and it lasts up to 10 to the minus 6 second, the quarks, neutrinos and electrons started to form. And during the hadron epoch, that is nearly around 10 to the minus 6 seconds, the quarks recombines to form the protons and neutrons, that is the hadrons. Then during that time, within very extreme condition, the electron collides with the protons and thereby releasing the neutrinos. And very interestingly, the neutrinos afterwards freely travels nearly at the speed of light. So, neutrino got decoupled from the rest of the matter. The hadron epoch ends. By the time it ends, then the hadrons and the antihadrons have annihilated each other. Then started the lepton era and that ended nearly till the first 3 minutes after Big Bang. So, during the lepton era, since already the hadrons and antihadrons have annihilated each other, so the mass density of the universe is dominantly the leptons and the antileptons and it all interacted. The electrons and positrons continuously annihilated and forms the photons and again from the photons the pair creation of electrons and positrons continued to happen. This is a picture till the first 3 minutes evolution of the universe. Afterwards started the Big Bang nucleosynthesis that started around 3 minutes and lasted until 20 minutes. So, what is the Big Bang nucleosynthesis? The Big Bang nucleosynthesis is the time when the first atomic nuclei were formed. The light element like hydrogen, then helium, then lithium were formed during that time through the nuclear fusion. But by the time of 20 minutes after the evolution, the energy and the temperature and the density of the universe were not sufficient to continue or sustain this nuclear fusion. So, it stops. So, during the Big Bang nucleosynthesis, that after the first 20 minutes, the energy density and the temperature of the universe has fallen down to such a level that cannot sustain the nuclear fusion reactions. So, after that, if you see the light element abundances, 75% of hydrogen, 25% of helium and few other trace elements like lithium and deuterium nuclei. So, afterwards came the photon era and the recombination epoch. So, it started around 3 minutes and lasted until 2,40,000 years after Big Bang. So, during the photon era, the photon interacted freely with the charged particles and the universe is considered to be filled with plasma, that is a hot, opaque and soup of atomic nuclei and electrons. And since the photon interact through the electromagnetic interaction to only with the charged particles, so photon will interact with the atomic nuclei, protons and electrons. So, most of the leptons and anti-leptons had annihilated by that time, by the end of the lepton epoch. So, there mostly the dominant one is coming from the photon. So, after that the recombination and decoupling epoch started. So, it started around 2,40,000 years and ended around 3,00,000 years. So, as the temperature of the universe falls to around 3000 Kelvin, then at that time the recombination happens, means the atomic nuclei, the charged atomic nuclei like hydrogen and helium captures the electron. So, this is known as a recombination, thus it neutralizes the charges. So, now the electrons are attached to the atoms and thus by the universe is now transparent to radiation. The photons now move freely, and if we see the picture of our universe during that time, that is provided by the that is known as the CMBR or the cosmic microwave background radiation, as we see from the satellite experiments of Kobe, WMAP and the Planck. So, mostly we have seen the view of our universe when it is only 3,80,000 years old, that is still called a baby universe compared to today. So, during that time, that is the time when the photon has last interacted. After that the photon moves freely. Okay. So, in 1992, first picture of this universe for the CMBR came through the Kobe satellite, and then in 2003 with a higher resolution, Kobe has provided the resolution of 7 degree, whereas in 2003 the WMAP satellite that has provided an image of half degree resolution, and finally in 2013 and so on, the Planck satellite is giving us the highest resolution images of the CMBR universe, that is at 0.07 degree resolution. Afterwards started the dark era. So, what is the dark era? The time between the formation of the first atom and the formation of the first star, that era is known as the dark era. So, it started around 3 lakh years and it continued till 150 million years. Okay. So, it is literally dark because there are no star formation to shed off light. So, the universe during this dark era is mostly dominated by the mysterious dark matter. Afterwards came the reionization epoch, which started around 150 billion years and it continued 150 million years and continued up to 1 billion years. So, the reionization epoch that started around 150 million years and ended around 1 billion years. So, during the reionization era, the first quasars were formed due to the gravitational collapse and that emit an enormous amount of energy and thus by reionizing the universe. Now, the most of the universe goes from being the neutral state to the state where it is being consist of the ionized plasma. So, that is the important phase of reionization. Afterwards started the formation of stars and galaxies. The star formation started about 300 million years after Big Bang. So, the gravity amplifies the density fluctuation and thus started the beginning of star formation. So, the small dense cloud gas started to collapse under its own gravity and thereby releasing a huge amount of energy to trigger the nuclear fusion. And when the nuclear fusion started, the star is born. The first stars are very massive and these are known as the population 3 star or sometimes it is also called the metal free stars. Afterwards, the generation of population 2 and population 1 star began to form with the remnant of the previous round of star formation. So, likewise started the formation of galaxies, the largest stars that again burn out and that explode into the supernova explosion. There are large mass or large gas in the universe which again collapsed and started forming the galaxies. So, this is the era near 300 million to 500 billion years. Okay. So, the galaxies are again attracted by the gravitational interaction and thus forms the clusters and superclusters. Now, nearly around 8.5 to 9 billion years after the Big Bang, our very own solar system was formed. So, if you see the structure formation of the universe as it was theorized and simulated by many of the cosmologists, you can see the picture starting from the very early redshift to the present redshift and how it has evolved. So, now the age of the universe as today is 13.7 billion years and we see the universe now as it is. So, it is expanding and the stars are continuously forming and galaxies are also forming. So, that is about a brief overview of the evolution of the universe. Now, I would like to conclude my session with the famous saying of a famous cosmologist and astronomer Carl Sagan, that cosmology brings us face to face with the deepest mysteries, questions that were once treated in religion and myth. Thank you all.